Hello everyone. Today let us talk about a very basic problem in PDA, that is designing a PDA for an odd palindrome. In this we can get two different kind of problems, that is even palindrome and odd palindrome. The question is like even palindrome, that it is in the form of w power r. It is odd palindrome, then it is wc w power r. But before moving on to the designing part, let us have some basic idea of what is PDA, what are its operations. As you guys know, PDA stands for push down automata, which is generally used to recognize a context free language which is generated by a context free grammar. It is represented with 7 different tuples, and here are the tuples you can see. And we have to understand that PDA performs 3 main operations based on which we are going to design our PDA for this odd palindrome. Those operations are push, pop and no operation. These are the basic syntaxes that we need to utilize. For example, if we are at Q0 and we are taking input A, and if there is nothing in the stack, so we are writing this simply Z0. If you want to perform push operation and we are going to the next state, it will be q1 comma a z0. If you want to perform pop operation at q1, if you want to perform pop operation, so q1 comma a comma z0, if you are getting, we simply write q1 comma epsilon. And if you want to do no operation, then q1 comma a comma z0 will give q2 comma some z0. These are the 3 operations we need to understand, because utilizing these 3 operations only, now we are going to design our PDA. So let us move on to the designing part. Okay, so let us take input a comma b, and w we can take anything, it is our wish. Using a and b we can take any string. So w I am considering AABA, so w power r, obviously it will become ABAA. Now if I write the final string, it will look like AABA CABAA. Now let us design a PDF for this. First of all, we are at state Q0, we are at the initial state. Now our main agenda is that whatever the inputs that we are getting before C, we want to just push them into the stack. When it comes to C, we are performing no operation, and after that, at the top of the stack there is A, just popping A. If at the top of the stack there is B, we are just popping B. So first of all, what we are doing, we are just pushing all the inputs which are before C. So C is our central element, we can say, okay, center point we can say, yes. Now if I want to push A, there is nothing inside the stack is empty initially. So if I want to push A inside the stack, the top of the element is Z0, so it will become AZ0. Now for example, I am not taking A, I am taking B, because if I am taking a palindrome may look like AB BA or BA AB also, isn't it? So if my first initial input is B and there is nothing in the stack, so it is Z0, so I am going to get BZ0. Similarly, I am writing all the possible cases. For example, there is A, on the top of the stack there is A, so AA. If I am taking B, and the top of the stack is A, so I am going to get BA. If it is A, the top of the stack is B, I am going to get AB. And finally, if I am going to take B and B is at the top of the stack, I will get B. So these are the 6 possible cases that we may get while pushing the inputs into the stack. Now we can repeat it anytime, so that's the reason why we have used loop here. Now what we are doing when it comes to C, we are performing no operation. So maybe the stack would be empty. If I want to push C, if I am at C, I will perform no operation. So C comma Z0 will give Z0. And if at the top of the element it is A, either A or B, so here also I am performing no operation. Now from Q0 to Q1 I am reaching, and at Q1 here we have crossed C. Now whatever the element comes, we just want to pop them out. For example, I'm encountering A and there is A at the top of the stack, I'm just popping it out. Similarly, if I'm encountering B and B is there at the top of the stack, I'm popping it out, and finally the stack will be empty. With the epsilon move, I'm going to get the final, I'm going to get into the final state. Okay, this is how we design a PDA, and if you want to check whether our PDA is correct or not, we can simply apply instantaneous description. So here let us do it for the given for the example that we have taken. So here Q0, comma AABACABAA, and there is nothing in the stack, so it is Z0. So first of all, what we are doing, we are pushing A into the stack. So this is how, so A will be pushed. Now after that, again another A is there, A will be pushed, then B will be pushed. Now when it comes to C, we are performing no operation. Now next, when A is there, the top of the stack also there is A, so we are popping it out. Again now B is there, at the top of the stack also there is B, so we are just popping it out. Again A is left, popping it out, finally A. So this A also we are popping it out. Now finally we are left with the empty stack. So finally we can say yes, whatever the PDA that we have designed, it's absolutely right. So this is how we design a PDA. In order to design it, we must understand three basic operations that PDA holds, and we can apply the same concept for designing an even palindrome, that is W into W power R.